Hello, my name is Rudy Montayre. I'm a rising senior at Montayre Catholic High School, and today I'm going to be talking about the design of an electroencephalographic or EEG-controlled electric wheelchair. My mentors are Gregory and Tsz Ho Tse. As you can see, I've already done a short little demo on the wheelchair, bringing that in. So this summer for the Young Dawgs internship program, I was working at the UGA Medical Robotics Lab. Here at the lab, they work to integrate engineering and robotics into finding medical solutions. They have designed many MRI-compatible products, and they do many outreach programs. Here's their website if you're interested for more information, as well as a picture of the team. These are a big group of guys. So some background on why we need this chair. Over 100,000 people in America have tetraplegia. Tetraplegia is paralysis from the neck down. Now there have been some mobility solutions to this before, one of which is a tongue-driven chair. Here you can see that there's a large metal retainer in the person's mouth. This can make it hard to eat and very uncomfortable. It's very big and bulky. It's also very expensive. There have also been personal nurses who are slightly problematic because they take away your sense of privacy and independence. But what we are proposing today is an EEG-controlled wheelchair. This is much more comfortable, it's much more cost efficient, and you won't need a personal nurse for everything. So now we just have a short another video demonstration. As you can see, I'm able to turn all different left and right directions, go forward. Yeah, when I was making this video, it didn't quite go the way that I wanted it to, but it still delivered the point that I was able to move this hands-free. Originally, there was a song behind this as well. So, to briefly explain how it works. Signals are detected with the headset from the brain, and it wirelessly sends them to the computer. The computer translates them and sends them to the interface, which is the Arduino microprocessor. That sends different voltages to the wheelchair, making it move whatever direction we choose. And now I'm going to go into more detail on each of these. So we'll start with the brain. Here you can see a picture of the headset with the different electrodes attached. What this headset can do is detect the different levels of concentration by reading the EEG signals. It can also detect facial muscle movements as well as the emotional state. And it wirelessly sends all of these signals to the computer. Here on the right, you can see a picture of the control panel. This is the headset tab that lets you see how well these electrodes are connected. Green being the best connection, and red or orange being a little bit worse. So signals are sent from the headset to the computer. The signals are received by the Emoto Epoch control panel. This receives the signals and types the corresponding key to whichever movement we've done. So it types the key into a program we call TerraTerm. TerraTerm just sends signals from the computer to the Arduino. The computer also serves as a power source for the Arduino and the wheelchair. Here you can see a couple pictures of the computer mounted on the back of the wheelchair. So with the computer, you can set certain movements and concentrations to key for certain controls. With the headset on, I'm smiling, and on the control panel, the robot mimics my movements and types the corresponding key. As you can see how it's glowing orange, it types a D. You can also see how you can change the sensitivities with this tab. Here's another example of another movement. Funny faces. I'm raising my eyebrows, and the robot raises his eyebrows and types an S key. Also in the control panel, we have the cognitive suite. This can read the EEG data and type the corresponding keys as well. As you can see, I'm concentrating with one of the higher powers, and it's pushing the box backward into the screen, therefore typing the W key. You can set different movements and different actions for the box to do. So next we have the interface. So signals are sent from the computer to the interface, and those are read by the Arduino. With the Arduino code, we've set it so whatever letter we type, it delivers a certain voltage to the wheelchair. And the varying voltages indicate which direction we want the wheelchair to go. High voltage means to go in one direction, and a low voltage would mean to go in the opposite direction, while a medium voltage would mean to stay still. Here we have a picture of the Arduino and the shield that I've made for it, and I'll explain that a little bit. Here we have the Arduino code. This is just a short little snippet to show that with different voltage inputs, we can make it go different directions. Next we have the shield assembly. Here we can see the shield that I've made for the Arduino. You can see the small little bits of metal on the top left picture, and that's called solder. I did this with the soldering station here in the center. What soldering is, it's low temperature welding. It lets me attach things, and it also makes electrical connections. So I had to attach everything on the bottom of the shield right here. You can see I wired up some of the outputs and also attached some capacitors and resistors. And what those do is it averages out the voltages that we want to send. And I was able to measure these voltages with the oscope or oscilloscope, which you can see on the very right. So the interface. Wires run from the Arduino to the wheelchair controller. Here you can see a picture of the hacked or modified wheelchair controller. We've wired it up so that it responds to whichever outputs and voltages we decide to use. Here we can also see that this joystick is not the original one. I replaced this with an Xbox joystick because the first one was broken and it was a lot of fun. I was also able to 3D print a placeholder, which you can see that small black thing on top. This was also a great opportunity for me to learn how to CAD, which is just designing things that I can print with a 3D printer on the computer. Here's a couple pictures of our 3D printing stations here at the Medical Robotics Lab. These are solid doodle printers, and yeah, they do a great job. Really fun to use. Definitely my favorite part of the lab. Here you also have a short 3D printing demonstration. So what this does is it melts the plastic and then inserts it into the shape that we want. Here you can see it's making one of the prototypes. You can see all the different prototypes here on the bottom. In the top right, excuse me, I made the final project, which was the black one. So engineering design, a learning experience. Now I'm just gonna explain these pictures briefly. Here in the top left, you can see that I'm wiring up the wheelchair controller, fixing that up properly. And the bottom left, I'm practicing using the wheelchair. In the center, I'm placing the Arduino and the shield into its project box. In the top right, I'm drilling a hole into the project box. And in the bottom right, I am configuring the wheelchair control panel. So I'd like to take this opportunity to talk about a couple of concerns and hardships I've had about this internship. So prior to coming to the lab, I had no experience whatsoever with any type of engineering or robotics, so that worried me a lot if that was going to hinder my performance making this project a success. But that was not the case. Everyone at the lab was a great help. They did a great job teaching me all different things. I was able to learn so much and eventually make this wheelchair a great success. And one of the larger hardships that we've had was learning to control the wheelchair. It was not easy at first. We've had to do a lot of practice using the wheelchair, as well as editing the code for the wheelchair, trying different programs, messing with the sensitivities, lots of different things, but eventually we got it to work the way it does today. So, are there any questions?
I have a question. Okay, it took you a while to get the wheelchair to work, but
Yeah.
in order for it to work, evidently, you had to use your brain and concentrate in different. So you had to learn how to control your concentration. I mean, what?
Well, if you don't mind me going
No,
through
I don't.
the slides.
Okay.
Here you can see the cognitive suite. This is
Mhm.
what was used to measure the concentration. And I wish this laser pointer was working. But with the trainings, you can train your neutral mind state, so you just be calm and relax, and it won't do anything. But here you can train yourself so you can concentrate, and it'll remember that state of concentration every time you try to make it go forward.
Okay. One other question, say a person that's under extreme stress, and that has not been, you know, something happens and you just stress out and you're in the wheelchair. Did you all do any experiments with that and how that was controlled?
Well, just in case, we did put a manual override. We do realize that if they do have some type of paralysis, they can't quite use that. But we made stop keys, and we have suggested to put the highest sensitivity on those stop keys so that works above everything else. We also put that first in the code, so that overrides whatever else we input.
Okay.
Any other questions? Yes.
What are your thoughts or your hopes about the future of this type of technology?
Well, I hope this comes out to be widely used, and I also hope that places learn to, make more wheelchair ramps and things like that. Just make general places and public places more accessible to people who need devices like these, and I hope that these become more widely used across all the nation and hopefully the world.
Are there any out there in the test, as a test group?
I think these have been tested before, but this is,
So there are people who are actually using them now?
yes. People, there's other solutions like the tongue-driven chairs similar to this, but
But it's-
not quite using the headset, and, just many different approaches to solving this problem.
How much would that cost, do you know?
Well, the headset was about, I want to say like 200, I want to say. It was a little pricey, but in comparison to things like the retainer, which end up being much more expensive, and personal nurses who you have to pay on the weekly, this ends up being much more cost effective.